Hi everyone, it's me DanielAryee3. Welcome back for insightful tutorials on the full mathematical appendix in support of Segment 1's tutorial, including a layman's approach and explanation in addition to a rigorous one with worked solutions. Yes, today join me as I provide a much simplified explanation to the main concept in Segment 1. Thus, specifically, in this tutorial, I provides a supplementary alternative illustration of the concept in Segment 1. Yes, a simplified version that supports the main tutorial, without the use of technical parameters and jargons exhaustively. In addition, I have provided worked example and solution in pen. Watch and follow me as I work out the detail up to the final answer. Okay, let's go. Alright. To this end, let's consider an alternative layman's explanation to the concept of expected value, or what is called mathematical expectation in Segment 1 of the main tutorial in order to better grasp and increase our knowledge and understanding of the concept. Thus, in business and economics, the idea of optimal investment decision making is common. Hence, whenever we are presented with investment options, we can make use of the expected value formula as a mathematical tool to determine the best choice or make the optimal investment decision by using the expected value formula as a tool. Yes, this elegant mathematical tool combines both the projected or potential profits and losses associated with each investment, thus capturing the combined effect, which is not only based on the magnitude of the profitabilities, but also the assumed or potential losses, including its probabilities to determine the ultimate profitability of each investment option. It also helps in the ranking and selection purposes. In other words, to determine the profitability of a particular investment, we do not only look at the positives, but also negatives of that investment, including associated degrees of probabilities or likelihoods, chance, before determining the profitability. Indeed, it helps us not to either underestimate or overestimate the true profitability by clearing out any false judgment or misinformed decision, so we can confidently select the optimal or make the best investments decisions among many choices. Alright, finally, let's look at how it plays out in a layman's approach. Yes, perhaps in this loose sense or framework, we will consider the following scenario in agriculture. For instance, a situation where we have two crops, say tomatoes and onions. Assuming we hold all other factors constant, including probabilities, and say the projected or potential profitability and losses of tomatoes and onions are given as $12,000 per acre and a loss of $8,000, with onions assigned a profit of $6,000, but with a potential loss of $1,000. Now, in this scenario, if we have to consider not only the profitability but also the associated losses, in other words, consider both the positives and negatives as dictated by the mathematical expectation concept or formula in the above, we will realize that a simple calculation, thus $12,000 profit minus $8,000 loss, yields $4,000 net profit for tomatoes and a $5,000 net profit for onions per acre. Thus, the $6,000 profit minus the $1,000 loss. Thus, it is now much clearer and conclusive that though tomatoes initially may appear very attractive with a much higher profit per acre, if we incorporate the associated or potential losses in the calculation of the profit, we cannot accept it to be the best investment crop because, on the contrary, it has the lowest profit comparatively to onion farming after considering losses. Thus, by applying the mathematical expectation theory, it turns out that onions are the best investment crop. Yes, this reveals the power of the expected value theorem, or the mathematical expectation concept, as its power lies not only in helping us to determine the magnitude of profits in the long term on average, but also helps us to rank various investments for comparative purposes when it's come to selection or choosing the best/optimal investment, i.e. when making investment decision. Good. Okay, now that you have additional understanding or a better assimilation using this loose framework or approach, let's then swiftly consider and focus on a more rigorous mathematical approach. that fully incorporates the formula and all factors to solidify our understanding. Yes, specifically the expected value, also known as mathematical expectation, is the average of all possible values of a random variable, weighted by the probability of each outcome. It's a generalization of the weighted average. This is how it is calculated. The expected value is calculated by summing or integrating the possible values of a random variable. Okay, now based on this definition, let's carefully look at the following case. Worked example and solution by DanielAryee, November 16, 2024. Question: Decision-making in business and economics, applied mathematics. Now suppose a company is deciding between two investment options. The first option, A, has a 50% chance of yielding $10,000 profit and a 50% chance of yielding $5,000 loss. The second option, B, has a 75% chance of yielding $6,000 profit and a 25% chance of yielding $2,000 loss. To decide which investment option is better, we would have to calculate the expected value, average outcome, of each option. The expected value, EX, of a random variable, X, is calculated as expected value equals sum of outcome X multiplied by probability of the outcome. Thus, in this example, we'll calculate the expected values for both options, A and B, and compare them. Hence solution step 1. Calculate the expected value for option A. Now because option A has a 50% chance of yielding a $10,000 profit and a 50% chance of yielding a $5,000 loss. By using the expected value formula above, it implies that the expected value of option A, I.e.A, is equal to $10,000 multiplied by 0.5, which the first outcome in the sample space of option A, plus $5,000 multiplied again by 0.5, which is the associated probability or chance. However, here it must be noted that the value of the $5,000 must be negative or negated, since that is a loss, thus negative $5,000. Next, by calculating each part in formula or equation, we end up getting $5,000 for the first part, which is the profit, and $2,500 for the second part, which is the loss. Now, by adding up the two parts, again here it must be noted that we will end up subtracting $2,500 from $5,000. Therefore, the final profit, or net profit, for option A is $2,500. Therefore, we can now conclude that the expected value of option A is $2,500. Okay, now let's move on and do the calculation for option B. Using same analogy, let's start by calculating the expected value for option B. Okay, since option B has a 75% chance of yielding a $6,000 profit, a 25% chance of yielding a $2,000 loss. In same manner as above, by using the formula, the expected value for option B is equal to $6,000 multiplied by 0.75, which the first outcome in the sample space of option B, plus $2,000 multiplied by 0.25, which is the associated probability or chance. However, here it must be noted that the value of the $2,000 must be negative or negated, since that is a loss. Thus negative $2,000. Alright, now, by calculating each part in the formula or equation, we end up getting $4,500 for the first part, which is the profit, and $500 for the second part, which is the loss. So by adding up the two parts, again, it must be noted that we will end up subtracting $500 from $4,500. Therefore, the final profit, or net profit, for option B is $4,000. So we can now conclude that the expected value of option B is $4,000. Now finally, we have to compare the expected values. Right, so expected value of option A is $2,500, and the expected value of option B is $4,000. Therefore, since the expected value of option B is $4,000, and obviously higher in value compared to $2,500 final or net profit of option A, the company should choose option B as it offers a higher average return based on the probabilities. Now, to stretch this tutorial a little further, I want you to learn that based on the information we have now about the expected value of the various investment options, we can leverage on that to derive additional important information or statistics like the mean, standard deviation, etc., that is relevant for the company's investment decision making as well. For instance, the expected value of option A's profit, which is $2,500, is normally distributed with a mean of 0 and standard deviation of 1. In a simple interpretation, what this means is that the mean of option of being 0, in other words, indicates that all possible profits that the company could expect to earn from that investment option A is equally, symmetrically, or normally distributed around that expected value of $2,500, both to the left or right of it under the normal curve from its mean position. Or better still, we can say that investment option A is symmetrically centered around its expected value of $2,500 because it has a mean of 0. Besides, this expected value of $2,500 is what the company could expect to earn in the long run as it continually invests in option A. Besides, we can also say it is the long-run average. Meanwhile, for clarity purposes, it is equally important to note or add that the mean of 0 does not indicate $0 profits, rather it is used in the parlance of standardized normal distribution, i.e. z-score, to indicate that the expected value of $2,500 corresponds to the z-score or value of 0. Okay, now, on the associated standard deviation of 1 means that a large proportion of the possible potential profits outcomes are also within just one standard deviation from the expected value of $2,500. In other words, the company can expect not to earn a profit that is significantly higher or lower than the expected value of $2,500. Thus again, the variation in profit other than $2,500 will always be relatively small. Hello dear one. Please, in order to further deepen your understanding, you can take a little time to observe the normal curve or associated graph above which I have provided. You will observe that by using a minimum varied starting from today expected value of $2,400 or maximum varied expected value of $2,600, I.E. lower and upper boundaries of $2,400 and $2,600 respectively, in the calculation, you will clearly see that the associated normal curve I have provided confirms that indeed these values are more likely to be within a standard deviation of positive or negative 1. Yes, very close to the expected value of $2,500. However, the full details of the calculations and explanations regarding standard deviation, variance, etc. shall be covered in another or future tutorials. Once again, I am DanielAryee3. Thanks for watching, and for more videos like this, please don't forget to subscribe to my channel at DTechnology4. Yes, like and share this with anyone who needs comparatively deeper understanding about the concept. Indeed, stay tuned for the next series of tutorials on the application of this wonderful concept of mathematical expectation in other exciting fields, in both academia and industry. Before we move on to an entirely different concept or a related topic, again, this emphasizes the importance of this wonderful concept. As usual, keep expanding the frontiers of your knowledge and never ever stop learning. Take care. Bye.